Okay, what we're going to do right here is we're going to solve, using identities to solve and find ratios of trigonometric ratios. Okay, we're going to evaluate. And what we have here is we're going to be given in different problems of various trigonometric ratios. So I have an example of one that I did in my previous class, so you can probably look at this if you want to take this and try an easier one. But I'm going to do number 2 here. And what we have is we're going to find this, all right, all the ratios, trigonometric ratios, given that tangent of x equals square root of 3 over 3 and cosine of x equals negative square root of 3 over 2. Now, the first thing I always try to do is I try to find out, okay, where is this triangle located? Because whenever you do trigonometry, you're talking about triangles here. And so what we have here is we have a tangent. So tangent is going to be positive, all right? So if I draw my little, all right, I like drawing a little coordinate axis here. All right, and what we're going to do is we're going to find out where is tangent positive. Okay, so tangent is positive. I know this because square root of 3 over 3 is there. Now, tangent is positive in the first and also in the, all right, third quadrant. All right, third quadrant here. Because we have negative x values here. We have a negative y value there. So negative over negative makes it, all right, positive, and positive is always in the first quadrant. Now, the next thing is that we notice that we have cosine, which is also negative. All right, so where's cosine negative? Well, cosine is definitely not negative here in quadrant 1, but it is negative in quadrant 2 and 3. Well, since we already have tangent is positive in 3, guess where our triangle is? Our triangle is going to be right there. And so the angle we're looking at is actually this angle going around here. All right, that's going to be like our x angle. That's going to be in that quadrant. And what's going to happen is I'm going to just put a theta here because we're going to use our reference angle. And now I'm going to create, all right, my little right triangle. And I'm sorry for not making that very good, right? But that's what we have there. All right, so let's put in the ratios. What we have is cosine. So cosine is ka. All right, remember that. Ka is adjacent. So in this case, it's going to be negative square root of 3. And we know this is negative because H2 is our hypotenuse. The hypotenuse is never negative. So if you're wondering, oh, what is that? They're never negative. Now, this is definitely a, all right, 30, 60, 90 triangle that we created. This is going to be negative 1 right here. All right, so it's going to be a 30-degree angle. This will be 7 pi over 6. 7 pi over 6, so that's what the angle will be. Just telling what we know about our basic triangles. And so now we're going to find out our regular stuff. So now this is pretty easy. We're going to go sine of x. Sine of x is going to be opposite over hypotenuse, so it'll be negative 1/2. We have cosine already. We don't have to figure tangent already. We have cosecant of x, which actually is the reciprocal of sine, so it'll be negative 2. All right, we have our secant of x. Secant is the reciprocal of, all right, cosine, so it'll be negative 2 over square root of 3, or negative 2 square root of 3 over 3. All right, we have cotangent, all right, of x. Cotangent of x is going to be, all right, adjacent over opposite, so it's going to be just square root of 3. All right, and bada bing, bada boom, those are our answers. Okay, so whenever you're solving the trigonometric ratios, you want to use these two different values and figure out the quadrant first, draw our triangle, and then once you write out a triangle with all the sides, using the ratios, find out the sides, then you can file and solve the remaining trigonometric ratios. Oops. And here we go. So here's another one that we did. All right, so if you want to try this one out, all right, I'm going to put that, and then I have the answers, and I'll show those answers in a little bit. All right, trying one similar, we have tangent and secant. All right, you can pause this video and try it out. And here are the answers right there. Okay, all right, well, let's try another one. All right, what we did, I have another one, number 4. So if you want to just not look at this, but try number 4. But we're going to try number 5. All right, number 5 here. Now, on number 5, once again, we are given two different ratios. We have tangent of theta equals 2, and sine of theta is going to be less than 0. Okay, so let's do this. Well, tangent, when is tangent? Once again, tangent in this ratio is positive. All right, so positive 2. So positive is going to be the first. All right, and once again, the third quadrant. Okay, and here it says that sine, the sine, which is y, sine y. All right, we have y here, positive, y is negative there. So y's are negative for this angle here. Okay, so what is our angle we're talking about? Well, where is sine negative? Well, it's positive up here, can be first. So it has to be, once again, in the third quadrant. They're not always the quadrant, but that's what we have. This is our angle we're finding. This is theta. All right, and I'm going to use my reference angle. I'm going to call this little alpha. All right, or I can call it that was a little line right there for my reference angle. And I have that. I'm going to draw my 90 degrees. All right, triangle, and now I'm going to use this ratio. Tangent is 2, so that's TOA. Opposite is 2, adjacent has to be 1. All right, and so I'm now going to find the rest of these trig ratios, but I need to know what is the hypotenuse because a lot of them need a hypotenuse. So I'm going to solve this using the Pythagorean theorem. Okay, so we have 1 squared plus 2 squared, and that's going to equal, I'll call it h or c squared, h squared. So we have 1 plus 4 equals h squared. All right, we have 5 equals, well, just square root of h. We have only the positive portion because that is, all right, hypotenuse always has to be positive. And so now let's figure out the rest of these values. So sine, well, we don't have what sine is. I know sine is positive, or sorry, negative. So what is sine? Sine is going to be, oh, it's in here, negative and a negative, okay? Because it's negative on the x, because x is negative over here. Oops, x is negative over here. And then y is negative down here. So these are negative. I have to enter those. Make sure you do that. All right, so sine is going to be, all right, negative 2 over the square root of 5. All right, or negative 2 square root of 5 over 5. Sorry for the bad writing. We have cosine. Cosine of the angle. Cosine of the angle is going to be, all right, negative 1 over square root of 5, which is negative square root of 5 over 5. Tangent we have known as 2, and now we can find out the rest of them. We have cosecant of theta. Cosecant of theta is going to be hypotenuse over adjacent, so it's going to be negative square root of 5 over 2. All right, reciprocal of that. Secant of theta is going to equal, all right, where is that? Reciprocal of that one is going to be negative square root of 5. And then cotangent, all right, cotangent of the angle is going to be reciprocal of tangent. We have tangent of 2, so be, all right, 1 over 2. There we go, or negative 1 over negative 2, which gives us positive 1/2. All right, let's see if I have any other ones. All right, here's another oldie but a goodie. All right, right here, this is a good one. All right, if you want to walk through this one. All right, what we have here is cosine of pi over 2 minus x equals 3/5, and cosine of x equals 4/5. Now, this is one we're going to use a trig identity. All right, so cosine of pi over 2 minus x. Both these are cosines, so the first thing is we have to figure out what is our quadrant. Well, in order to figure out our quadrant, we probably want to get rid of this, because this is identity, and if you know, this is a cofunction identity. And what we have is this is actually cosine of pi over 2 minus x is actually equal to sine of x, sine of x. So sine of x equals 3/5. Cosine of x equals 4/5. And so, knowing that now, we know that we have both positive. That's going to be in the first quadrant. It's going to be a 3, 4, 5 triangle. The sine is opposite over hypotenuse. This is going to be adjacent over hypotenuse there. From here, we can once again do all of our trig ratios. We know we already have sine of x. All right, we already have cosine of x. We can now find tangent of x. Tangent of x is going to be 3 over 4. We can find secant, or cosecant, I'm sorry, cosecant of x. Cosecant is the reciprocal of sine, which will be 5/3. Secant, reciprocal of cosine, which will be 5/4. And then cotangent of x, reciprocal of tangent, which is 4/3. All right. Well, I hope this helps you out in how to solve these various trig problems. Whenever you're given these two values, two different ones, and you have to find the ratios of all the remaining ones, key thing is use these two angles, they are clues, to find the quadrant where your right triangle will be located. Use these, all right, and use the ratios then to set up the sides of a right triangle. Because in order to figure out the ratios, you need sides of a right triangle. And from here, use a little bit of so, ga, toa, all right, and then reciprocals, all right, to find out the remaining trig ratios. So hope this helps you out. Good luck and God bless on the rest of your trigonometry problems.